Hello everyone, let's continue with another lesson about C# for beginners. This is going to be an easy topic, but important one, because we are going to discuss access modifiers. From their name you can probably deduce that they are some concept that alter the access level of something. They are actually reserved keywords that add information for the compiler and the piece of code related to those modifiers. Even though they might seem abstract and confusing, you'll see they are not. C# has 5 access modifiers: private, public, protected, internal, and file, and some combinations of them like private protected and protected internal. Let's see what they do. You saw this code example in previous lessons. We have a class defining how a book object should look like. Then we declare a variable of this book type, and we set the value of some variable title for this book that we created. But if I modify this public keyword into private, we will get a compiler error. Come on. Which says book.title is inaccessible due to its protection level. This means that title is no longer accessible from within program, and in actuality, private means that this member, this title variable, is only visible inside the class book. So it's visible only inside the class it was declared, in all the methods and so on. But it's not accessible outside of it. On the other hand, when it was public, it was perfectly accessible. And this is a general rule. Private is the most restrictive access level modifier because it's visible only inside that class, and public is the most permissive one because it means accessible from anywhere, no restrictions. One odd access modifier, even though Microsoft categorizes it as a type modifier, is file. So if I add a new class to my project and I give it a distinct file name, but then I change it to have the same name as the existing class, I will get a compiler error because, as explained in the previous lesson about namespaces, you cannot have two classes with the same name in the same namespace. And because this one has no namespace, it's placed in the global namespace, just like this other one. But if I change it to have the file access modifier, the visibility of this class is restricted only to the file is declared in, so only in book file, and it takes precedence over other classes named the same way in the same namespace. There are a few rules that involve this access modifier, like for example, it cannot be used as the return type or parameter of a member that has other visibility other than file, it cannot be used in nested types, it cannot be used with other access modifiers other than internal, and others, but that's not important because this access modifier was intended to be used with source generators, so automated code writing, and that's a topic I'm not going to get into, at least not today. The next access modifier, protected, is related to a topic we haven't learned yet, inheritance, but in short you have two classes, one inheriting from the other, thus receiving its accessible members as if it had them itself, like this. So we have a base class called animal and a class inheriting from it called cat. And as I already mentioned, private is visible only inside the class it's declared in, which means age is visible only to the members, to everything that is declared inside the body, the block of code of animal, not inside cat. On the other hand, it, since it's public is accessible everywhere, which means accessible inside animal, inside cat, inside any other class. Protected is the keyword that says this member is visible inside the classes declared in animal plus any other chain of inheritance, which means any other class that directly or indirectly inherits from animal, like cat. This will make a lot more sense when we will learn about inheritance, so for now don't stress about it. For the next access modifier, internal, we need to learn a new thing first. So in the last lesson we learned how to deal with multiple files in the same project. Today we are going to learn how to deal with multiple projects in our solution. So go to Solution Explorer, right click but on the solution, not on the project, and go to Add, New Project. Select C# all platforms library, and then from this list class library, hit next, give it a name. This one you don't need to change, hit create. And now if I look in Solution Explorer, we have two projects, so I'll collapse them to make a point. We have Hello World and some library. Hello World is the one we had created before, and is the default project, is the one that will be ran when we hit this play sign. and it's outlined with a bold font to indicate that it's the start type project. But then this sum library is the project we just created, and inside it we have this class 1, which is this one right here, public class 1. So let's try to use it just like we tried to use in previous lesson the book class. So we get an error. Well, maybe class 1 is not declared in the same namespace as we saw before. So if we look here, it says namespace sum library. Okay, we need to import it first. But this also gives us an error. Why? That's because these are two separate projects. They have no relation or knowledge of each other. Even though they are in the same solution, they are not connected in any way. In fact, each of them will produce a separate assembly, a separate executable, a separate program. So in order to correct that, we need to go to dependencies, add project reference, and select the project we want to reference. We want to access stuff from some library from within hello world. Therefore, we need to reference some library from hello world. We select it, and now we have a reference, and the error will go away. Thus, proving my point that class 1 is some library.class1, and it's accessible because it's public. But if I change it to internal, I will get an error eventually. That's because that's what internal means. It's sort of like public, accessible from everywhere, but restricted only to an assembly, only to a project. Only within this project is accessible everywhere. This is useful when you develop a library and you want some class to be accessible throughout your project to make use of it, but you don't want it to be accessible to the users of your library. To understand what I mean with this library thing, let's first undo the access level so it's accessible and we don't get a compiler error. Then let's rebuild the solution, right click, rebuild solution. This will recompile everything in the solution, all the projects. Then right click on the project, on the startup project, hello world, and choose open folder in file explorer. This will open Windows Explorer to where this project is located. Then go to bin. This is the directory where the executables will be placed when you compile them. Debug.net 8. And here we have hello world.exe, our program, but we also have some library.dll. This DLL means dynamic link library. Not important what that means, but this is the reason why we chose class library when we created this project. Class library is the type of project that would create this some library.dll, this DLL file. But why do we have some library.dll in the same directory as hello world? Because remember, these are two separate projects and they will produce separate executables. So if I go to hello world, the directory of our solution, we have two directories, hello world and some library, one for each of our projects. And some library has its own bin, just like hello world does. And debug.net 8. And indeed, it's creating its own assembly, its own executable, some library.dll. Then why is it copying it? Why is it duplicating it also inside hello world? Let's go back. And well, if you remember, we added a reference to some library from within hello world. In order to use class 1, which is defined in some library, from within program, which is in hello world, we need to add a reference. And reference means copy that executable, that DLL, in this directory too, because class 1 is defined there. And if you don't copy this DLL, I don't know where to look for that class. I don't know where it's defined. That's why it's duplicated here, because hello world is referentiating it. We will deal a lot with this class library and DLL projects in future projects, but for now, if you are wondering where and why would you use something like this, imagine you are developing a huge game. You don't want all the code of your game to be in a single project. Maybe the graphics rendering should be a separate project, multiplayer and networking another project, etc. So individual teams can work on individual projects. And not only that, they are logically separated. When you need to find code related to multiplayer, you know where to go, not look in all the code. Quick tip. The only difference between an exe file and a DLL one is one of them needs to have a main method. exe files are intended to be executed standalone. So when you double click it, the operating system needs to know where to start the execution, which is the first method to be invoked. And the main method is that method. That's why it's called the execution entry point. On the other hand, DLL files don't have a main method because they are not intended to be executed standalone. They are intended to be referenced from executable files, from exe files, and to be used like that, to reference code from them. There are two more access modifiers that are combinations of the already mentioned ones. The first one is protected internal, which means internal, visible everywhere in the current project, the current assembly, plus any inheriting class, even if it's defined in other projects. On the other hand, private protected means only inheriting classes in the current project. But these are odd ones, they are not that much used. Not only that, but they also have to do with inheritance, and inheritance itself is not that much used nowadays because there are better alternatives, like for example composition. One last thing about access modifiers is that they are always present, even if you don't see one. So for example, inside methods, the default access modifier is private. Everything that is inside the method can only be private. So if I try to explicitly write it, I will get a compiler error because the compiler knows that it cannot be anything else other than private. You don't need to manually specify it. Inside classes, the default access modifier is still private. So if I don't type it like this, this will be private by default. And inside namespaces, so stuff like classes, interfaces, we will learn about them in the future, etc. If they don't have an access modifier specified, they are internal. Done with this lesson. In the next one, we will learn how to use classes. Because we saw how to declare, structure, and access them, we need to see how they are used. If you like this video, do that virtually too. If you want to see more content like this, subscribe is also an option. For now, thanks for watching and for the interest, and I'll see you in the next stack frame.